She won't show me. She's like, I mean, you feel like, did you see it?
I'm on like the it's like so like we don't know like what skin guys.
Okay, guys. Page 23. We have one more topic to go over, and that's dealing with confidence intervals. So we'll spend today and tomorrow going over it to those. So we have 2 full class periods today and tomorrow, but I know next week our classes will be cut short, but we can start reviewing on Monday. Hope to get back your quizzes back on Monday. We'll review Monday, Tuesday, and then our test will be split up into 2 days, Wednesday and Thursday. Okay. So I'm going to read through the notes. I'm going to have you guys kind of copy down this as well. I'll try to zoom in, make it a little bit easier for you to read off of this. Okay, page 23. Okay, so I'll just read this opener here. Hey, let's say friends plan to meet Saturday morning for a fun day at Six Flags, and if you're told to be there at 10:30, then that's when you're expected to arrive, right? But then what other times could also be reasonable, right? It could be, if somebody arrives 5 minutes before, 5 minutes after, that's reasonable. 10 minutes before, 10 minutes after, okay, maybe 15. But, after 15, you're kind of wanting to double, check on something happened, they're stuck in traffic, right? So, if you're waiting on a friend and you made a time to meet, there's going to be some, right? You're not going to expect them to be there exactly at that time that you agreed upon, but then there's this interval that you think is maybe reasonable. So the question here is, would you be more confident to arrive, quote unquote, on time if you make your window of arrival wider or narrower? Right? You'd probably be more confident that your friend will show up if you give a wider interval, right? So that's the idea, is that we're going to be creating these interval of, whether within a certain confidence. So, if you have a higher confidence, your confidence in your interval will rise if you have a wider window, right? If you have a wider window, that means there's more chances for that person to reach that interval. But if you have a more narrow interval, then your confidence is going to be becoming less, right? If you're like, how confident are you that if you make an appointment with a friend that they're going to show up within a minute of 10:30 or that appointed time, right? They're not going to be very confident. But if you give your friend a 10 to 15 minute window on either side, then you're more confident that they're going to show up within that time, right? So the wider your interval, the more confident you are. The more narrow your interval, the less confident you are, right? That just want to make sure that we understand that concept. Okay, so the answer is going to be wider here, more confident with a wider window because there's more options for a reasonable arrival time. Okay, just want to get through some definitions here. Population includes all elements of a set of data. So population, you can think of it as, if we want to consider everyone in the U.S. If we're trying to find data, population would be including everyone. But a lot of times we have to kind of base that off of a sample, right? Let's say we want to make a generalization about data, but then, about all U.S. adults, but a sample could maybe give us some idea. So sample includes a portion of a set of data. So let's say you selected 3,500 adults and you call them randomly to gather data about something. Okay, parameter. This is a number relating to the population. So for example, uppercase N would represent everybody. Okay, so and then P would represent the percentage of that number. Okay, so let's say, for instance, U.S. adults who have a college degree. Okay, we have if we're relating to a population, we'll use P is equal to 30%. But then a statistic is a number relating to a sample. Okay, and we typically use lowercase n for sample. And sample percentage, we have this little kind of this triangular hat that sits above P to indicate that it's a sample percentage and not a population percentage. So let's say out of 3,500 adults that were surveyed, 28% answered that they have a college degree. So then we would indicate that with a percentage sample and not a full population sample, full population data. Okay, identify population, sample, and statistic for each of the following scenarios. A survey of 1,300 American households found that 32% of those households have basements. Population would be every American household. Sample would be that 1,300 that we surveyed. And then 32% is coming from that sample. So we have that percentage, or that probability is 0.32, but it's coming from a sample. So we have that little, that hat notation to indicate that it's coming from a sample and not from every from all the from the entire population. Okay, the average bill from every sixth person getting food at Chipotle in a 3-hour period was $18.61. Population would be every Chipotle customer. Sample would be taking, looking at or asking about the receipt of every sixth customer. And the statistic is the mean of that sample is $19.61. Okay, let me read the confidence intervals here. These are the intervals of plausible values for estimating a parameter with a given percent confidence. We use the sample mean to estimate the population mean. We use the sample proportion to estimate the population proportion. Okay, this question I think may come up a little bit later. So let me skip reading that, and let me talk about the formulas that we'll be using. Okay, we'll do. Let's talk about confidence interval for proportion. Let me just focus on this portion first. So confidence interval for proportion. We're going to be using this formula to help us get to our margin of error. Okay, we'll be given these formulas. We just have to be able to know how to use them. So sample proportion and decimal. So taking that decimal proportion, and that will go in for that P. And that will be provided for you in the problem. Usually the sample proportion is given to you in the problem. And then we have to find the z-score from the probability. So you'll be given some confidence interval. It could be like 90% or 95% or 80%. Convert that to a decimal value. And then once you get that percentage, you're going to use the chart to help you get to the z-score. And that will go in for z. So we're going to find the percentage first, convert it to z value, and then insert it here. And then the rest, the sample proportion is going to go inside the formula as well. Square root of p parentheses 1 minus p over n. N is your sample size. And this represents your margin of error. So margin of error, we're going to be doubling it to give ourselves an interval width. So for instance, if you say that you expect your friend to show up within 5 minutes of your appointed time, that means you're giving that friend a 10-minute window, right? Either 5 minutes before or 5 minutes after. So your margin of error is 5 minutes, but then your interval is going to be 10 minutes. So when we do plus or minus, we're going to be extending that interval, doubling that of the margin of error. But if we're talking about the population, then we'll switch over to this formula, sample mean, and the problem will specify which formula to use. Sample mean will be your X bar. Population standard deviation would be your sigma. A little bit cleaner, a little bit easier. We still find the z-score the same way. We take our percentage, convert it to a decimal, use the table to get it to z-score, and then we use this formula to get our margin of error. Okay, once you get that decimal, we can add it to the mean, and we'll do plus or minus the mean. And again, we're going to be doubling to get that interval width. I know right now it just feels like a bunch of formulas, but we'll practice through these problems and hopefully get more comfortable as we work through our examples. Okay, so give you guys another minute here, and we'll go over to the next page. Okay, have your calculators out. We'll be using that. Okay, everybody good with this page? Good. All right. Okay, there's page 24. Okay, so survey. We know we'll be using that first formula since we're dealing with a sample. So let me put the formula up here so we can. I'll put this on a separate sheet. I want to give myself enough room here. So I'm just copying the formula, that first formula on the previous page. Okay, let's gather some information here. Survey of 1150, so we know that's our n value, n equals 1150. 84.6% of respondents, we know that's the percentage that will go along with P. That's converted to a decimal, so what does that become? Okay, believes toilet paper roll should go over and not under. Construct the following confidence interval for the proportion of people whose toilet paper rolls over, and state the margin of error. Okay, so here is our C value. So we have that formula from the previous page that tells us to deal with the z-score, we're going to have to work through that percentage. That's our confidence percentage. So next step is to go through this formula, 1 minus C percent divided by 2, but we want to get this involved with a decimal. Okay, so 1 minus 0.9 divided by 2. Let me do that. Okay, so use your calculator. What's 1 minus 0.9 divided by 2? Okay, 0.05. Now this is still a decimal probability. So now we got to convert this to a z-score. Okay, so use your chart, use your table. Find 0.05 or to the best of your ability. And what's the z-score that's associated with 0.05? Okay. Wait, hold on, let me see. 5. I got this, negative 1.64 or 1.65. Either one is fine. I'm going to choose negative 1.6. Oh, sorry, negative 1.6. Yeah, these are the same distance away. So I'm just going to choose negative 1.65. Okay, is everybody okay with that? Everybody seeing that? Okay. But either one, I mean, if it was on the test, if it was like the same distance away, either will be fine. But for now, I'm just going to choose negative 1.65. Okay. Good there? Okay. So that's our z-score. That corresponds with this percentage or this confidence percentage. Okay, so really that's the hard part. The hard part is just trying to get to that value. Everything else we can just plug into the formula. Yes. Right, so we're looking for 0.05 to begin with. So 0.05, I'm just looking for 0.05 that shows up. And 0.05 shows up there.
Oh.
Right, 0.05 or 0.0495. These are both really close, but I'm just going to choose negative 1.65. Okay. All right. I think that's the hard part. Everything else we're just going to plug in. Okay, so go ahead and do that. So this is what we're going to gain is our confidence interval. So CI, our percentage, our sample percentage there, 0.846, plus or minus Z, negative 1.65. Oh, by the way, we don't have to worry about this minus sign because there's a plus or minus in front of it. So, you know, we're going to take care of that negative eventually. So we'll just go ahead and just write it once because if I have a negative here, it'll do the same thing. One will become positive, the other is negative. So basically, if you get your z-score, don't worry about the sign. The plus or minus will take care of it. Okay, 0.846 times 1 minus 0.846 divided by n. And what's our n value? Yeah, sample size. Okay, don't enter all this at once. We're just going to try to get this cleaned up. Okay, I just want to figure out what this decimal is. Okay, so enter in either a piece at a time or just make sure that we can do that. I'm just going to take care of what's inside the square root and multiply by 1.6, but you can just do other things as well, as long as we're making sure that we're getting our values correct here. Okay, so my radical gives me 0.0106. I'm going to multiply that by 1.6. Still got that z value sitting in front. So 0.01. Oh, sorry. My bad. 1.65. I left off that 65 there. Wondering why my answer was off. Sorry, 1.65. Okay, 0.178 or 0.018. I'm going to round to 3 decimal places. Okay, I want to talk about this number here. This is what we call the margin of error. Okay, so we know that because of our confidence interval, we know that we can do a give or take 0.018 to get that 90% confidence interval. So this is your margin of error. I'm going to abbreviate it as ME. So here's our full confidence interval, 0.846 plus or minus 0.018. So I'm going to get it into between two numbers. So I want my lower interval, my lower bound and my upper bound. So to get my lower bound, I'm going to do 0.846 minus 0.018. That's going to be the lowest value. And my highest value will be 0.846 plus 0.018. Okay, so enter in your calculator. Sorry. Oh, the 0.018 came from this mess of a value here. Does that make sense? Yeah, so all this gives me 0.018. Now, what I did in the calculator was I left it as a longer value. So I took this value, which is a lot more accurate. I'm going to add 0.846 to it. And then round it at the end. So 0.86. Let me see. Let me try again. Why my answer was a little bit. Yeah, sorry. 0.864. Okay, 0.864. And if I did 0.846 minus 0.01756, I get 0.828. So if I want a 90% confidence, then I'm going to set my boundary in these values here. So that's part A. That's with a 90% confidence. And then part B, we'll move on to 95%, which means that we're going to expect our interval to be wider, right? The wider our interval is, the more confident that we know we can have more room for error, right? If you have more room for error, you know that it's easier to hit those marks. So part B. So part B, the only thing that's different is your C is going to now be 0.95, which will change your decimal. It'll change your Z-score, but it'll change this value here. But everything will stay the same. Really, you're just doing the same thing. You're just making a slight adjustment to your Z value, which will obviously impact your margin of error, and which will also impact your confidence interval. Okay? But really, it's just the same process. You're just going to be changing this number, which is going to kind of snowball into kind of a domino effect for all the other values as well. Okay, so really we're just doing this process. We're just practicing through this process for the rest of the class today. Okay. All right, so try part B. Let me come around and see if you guys need any help. Yeah. Okay, so what I was doing before I did that. You'll see that. The square root is over everything.
I did earlier doing that one.
And then you divide it. Oh, okay, that's fine. Yeah, as long as your square, because it looks like your square root is anyway.
When I did it, I got.
Okay, yeah, so yeah, that's the issue. That 1150 is not going to square root. 1150 is, so you gotta make sure that's square root. Yeah, that should be better. Yeah, make sure that your square root impacts the denominator as well. So do square root fraction. Make sure that 1150 is sitting under the square root. Right, so your percentage will change a little bit. It'll be 1 minus 0.95 instead of 0.90 divided by 2. You get a different probability. Convert that to a z-score. And then don't worry about the fact that it's negative, because the plus and minus will take care of that negative inside. So just do plus or minus, just put the positive value, and look, everything else stays the same. Yeah. Right, how to get a z-score. So you take that 0.025 and you look for 0.025 on your chart. So here's 0.025. 0.025, there it is. Hey, hold on. Oh, okay, sorry. 0.025, not 0.0025. Okay, let me look again. 25. Yeah, negative point. Let's see. Oh, sorry, 0.025. Yeah, there it is. Negative, sorry, 0.025 is going to translate to negative 1.96. You guys see that? Yeah, so I would say this, that anything between 0 and 0.4 is going to be on the negative on page 2. Anything from 0.5 to 0.9 will be here. But yeah, it does seem a little bit out of order. But 0.0, you know that 0.02 is going to be it's going to be very, very small, right? It's less than 2%. So yeah, so you're going to just kind of search for it, 0.02. But yeah, generally they kind of, I know they're a little bit out of order within the rows, but then in general, once you have an idea where it is, you just have to look a little bit closer. Yeah. So maybe that's the hardest part, right? Just trying to get that that probability to a z-score.
The
Order that, oh, you mean the, yeah. So we want the smaller to the larger. Yeah, I always want to go from smaller to larger. Okay, any questions here? All right, so we're just going to try to get through the first page, and then we can save the rest for tomorrow. So let's just see how far we can get. Okay, but it's the same process for all these problems. Except, okay, when we get to number three, they start giving you information that's a little bit different. They give you mean and standard deviation. So then we got to switch over to the second formula. Okay, so, but number 2, I think we're still going to be similar to number 1. Okay, so number 2. Okay, sorry, something else that I didn't go over here. another formula that would involve here, they don't give us the percentage. They give us 770 people out of 2,500. So we have to go through a decimal here to get that sample percentage. So here, sorry, one more formula here, 770 divided by 2,500. Okay, so the previous problem, they give you that percentage, but here we're gonna have to find that percentage ourselves, 770 divided by 2,500. Okay, so now take that, go through your formula, 1 minus C divided by 2. That will get you to the probability that we care about, and then we can go z-score from there. Wait, hold on, let me check. Okay, hold on a second. 85%. My bad, my bad. This is the p. Oh, sorry, this is the p-value that we're going to use up here. Right, that's the p-value here. Okay, so we're going to save this. My bad. We're going to save this. We're not going to do anything else with it. Now we can move to the confidence percentage, which is that 85%. Okay, look on your table, 0.075. Negative 1.44. Now we can move on to our confidence interval. 0.308. Plus or minus z-score, 0.075. Big square root. P times 1 minus P divided by your N. Enter all this in the calculator to get your margin of error, and then we can solve the interval with that 0.308. Let me see. Oh, I messed up here. Sorry. What, that's my z-score is -1.44. Hmm. A little bit off here. Did you guys get 0.99 to 0.317? Let's see. Let me try it again. Okay. My answer is off. Okay. This is better here. Okay. Okay. This works. Sorry, I made a couple of mistakes here. But the p-value is first, and once you get that z-score, that goes here, and then your p-value will replicate itself in the beginning as well as inside the square root. Okay, number 3, we're given mean and standard deviation, so we're going to use a different formula here. This is the second formula that's on the previous page. So we'll use this formula here, x bar okay, so x bar plus or minus z sigma over square root of n. Okay, a recent survey of 133 Milton students, that's our n value. Daily screen time, average daily screen time is 5.402, that's our x bar. Standard deviation is 1.565. Construct the following. Okay, 80%. We're going to use this to do our to eventually reach our z-score. Mm-hmm.
You said we'll be given the.
Yeah, given them all the formulas here. Okay, before you write this. There's 6. 0.8 over 2. Guys, give me a moment here. Let me see where I'm going wrong here. So minus 0.8 divided by 2. You guys get 0.1? Okay. Point 1. You guys get z equals negative 1.28.
Yeah.
Okay, yeah. Okay, that's the challenge here, trying to get to that value. Okay. All right, so now everything should be ready for us, I think. .174. Okay, subtract 0.174 and also add 0.174, and we can get our interval. And we'll do one more. Okay, we'll stop at the end of 3. We'll do one more. What do you expect your interval to be if you want a 99% confidence? Will this be wider or more narrow? Wider, yeah. The wider you make your interval, the more confident you are that you're going to be able to meet what you're looking for. Okay, 0.005 is really, really small number. It should be on page 2 at the top of page 2. Negative 2.58 or 0.57. I'll choose 2.58. Okay, we'll stop there. Page number 3. Okay, let me check pages 23 and 24.